This will be for the con assignment, Radians and Arc Length. So an arc is basically a piece or portion of the circumference of the circle. So this portion right here highlighted in red, that is an arc. Okay, you can think of it as like the crust on a slice of pizza. Anyhow, this point O is the center of the circle, and this angle right here, it's considered the central angle. Okay, and it is represented by that Greek letter theta. And the central angle determines what percentage or portion of the circle the arc length actually covers. Okay, as you can see, the arc is a portion of the circumference of the circle. So we can set up a ratio and proportion based on the angles and the arc length. Okay, in this exercise, we're dealing with radians. All right, so if you go all the way around the circle, we know that to be 360 degrees, but in radians, it is 2 pi radians once around the circle. Okay, and this angle here is just a piece or portion of the entire circle. So it's going to be theta divided by 2 pi. And like we said, the arc length is represented by the letter S, and that is just a portion of the circumference. So the arc length S is the portion, and all the way around the whole circle is the circumference C. Now I'm going to show you a formula for arc length that you can only use when the angle measurement is in radians. But if you ever forget that formula, you can always revert back to this ratio and proportion. So we have our ratio and proportion here. Okay, theta over 2 pi equals arc length S over circumference C. Now, we know that the formula for circumference equals 2 times pi times r. So I'm going to plug that in place of C. Okay, instead of C, I'm going to write 2 pi r. All right, and if you'll notice, we have 2 pi in both of these denominators. So we can get that to drop out. If we just multiply both sides by 2 pi, it cancels on the left, 2 pi divided by 2 pi, and it cancels on the right, 2 pi divided by 2 pi. So we have theta equals S divided by R. Okay, this is just 1 right here, so we can ignore it. And solving for the arc length S, if we multiply both sides times R, we have S equals R times theta. So you can use that formula when the measurement is in radians, okay? S is the arc length. R equals the radius. And as we said before, the angle theta, the Greek letter theta, that is the central angle. So we're going to use this formula for this exercise, okay? But like I said, you can always go back to the ratio and proportion if you forget. All right, write a formula for arc length S in terms of R for the following figure. All right, so we just said a minute ago, S equals R times theta. All right, they want the formula for the arc length in terms of R. So, of course, it's going to equal R times something. All right, and we can see here this angle measurement. This is the Greek letter represented by the Greek letter theta. Okay, it's 1.2 radians. Okay, so S is going to equal R times 1.2. So we can just say S equals 1.2 R. That's it. Okay, so we wrote the arc length in terms of the radius R. That's it. So type 1.2 R in the box. It's just 1.2 times R. All right, what is the length of arc S shown below? Enter an exact expression. So S equals R times theta. We can see the radius R right here. That's 2 centimeters. And the angle theta, we can see this angle right here. That's theta. That's pi over 4. All right. So it's 2 times pi over 4. And reducing that fraction, 4 divided by 2 is just 2. So we're left with pi over 2. That's the arc length. Okay? You don't need to plug in 3.14. It says enter an exact expression, so you leave pi alone. Click inside the box, and you can click the pi symbol, or you can just type pi, and it will give you the pi symbol. Also, you can click the fraction, or you can just click slash on your keyboard, and then type the 2 in the denominator. So that's it, pi over 2 centimeters. All right, an arc subtends a central angle measuring pi over 2 radians. So subtends, what does that mean? Reaches from one ray to the other. So in other words, yes, this arc reaches from one ray to another, one radius to another. All right, and they want to know what fraction of the circumference is this arc. All right, so you do not need the arc length or the radius for this one. They want to know what fraction of the circle is this arc. Okay, well, there's actually 2 ways to do it. All right, they gave us that this is a right angle. So that's 90 degrees, and all the way around the circle is 360. So reducing that fraction, 360 divided by 90 is just 4. So it reduces to 1/4. So that's it right there. This arc is 1/4 of the entire circumference. Now, let's say they hadn't given you this right angle here. Okay, so this angle theta equals pi over 2. And we said at the beginning, all the way around the circle, in radians now, not degrees, all the way around the circle is 2 pi. All right, and when you divide fractions, you remember keep, change, flip. So we can make the denominator 2 pi over 1. All right. So we keep pi over 2. We change division to multiplication. And we flip 2 pi over 1. In other words, just take the reciprocal and make it 1 over 2 pi. All right. So this is gone. And now we can multiply instead. Pi in the numerator, pi in the denominator. Those cancel. And we just have the 1 in the numerator and 2 times 2 in the denominator. So as you can see, you get the same answer. So just in case they didn't give you this right angle, you're dividing by 2 pi. All right, so the fraction is 1/4. I'm going to type 1/4 inside the box. All right, they want to know what is the measure in radians of the central angle theta in the circle below. Let's see. We said S equals R times theta. Okay, S is the arc length. So as you can see, if you travel from here to here along the curve, that length is 6. So in place of S, I'm going to plug in 6. And the radius R is this length right here. That's 4. And the angle theta is this angle in here. We don't know theta. So it's 4 times theta. Solving for theta, we divide both sides by 4. Cancels right here. And 6 divided by 4. 6 divided by 2 is 3. 4 divided by 2 is 2. So that's it. All right, I just reduced the fraction. Let me see if Con makes you reduce this fraction. What happens if we type 6 over 4? Let's see. Inside the box, I'm going to type 6/4. Okay, so it actually accepted that answer. It didn't make me reduce the fraction, but it is a good practice. So I kind of suggest you try to reduce it if you can. But anyhow, it doesn't make you reduce it, at least not for this type of problem.